What would happen on an exam is question A, they would tell you they would like to see it algebraically. The other ones we're going to solve with techniques of guess and check and being smart about it. Okay? So for question A, if it was algebraically, n choose 2, you would go to your formula for combinations, and n choose 2 is n factorial over n minus 2 factorial times 2 factorial, and that equals 28. When expanding things, what's the biggest? Well, the 2 factorial is a number, right? That's just 2. But when expanding, can you see that n is bigger than n minus 2? So you have n times n minus 1 times n minus 2 with your n minus 2 on the bottom. Those will cancel out. I would still have the 2 on the bottom, but I could multiply both sides by 2, and you would get 56. Now, if you expand this, we'll get n squared minus n. Subtract the 56 over, because it's a quadratic equation, so you can factor. And when you plug in minus 7, you can't have minus 7 items choose 2 of them. That doesn't make sense, because that would cause you to put a negative into one of your factorials. But 8 works, and so that's the answer. Oops. If we look at B, yes, what we just experienced was a cake dropping in the hallway. Like one of those big Safeway ones.
Was it open? Yeah, it was. And it felt. It didn't have any like. It's still such a good cake, though.
Yeah, it looks like the cake will be fine.
Oh no, it's good. Like,
And we're recording this, and it's on YouTube, so it'll all be good.
okay, yeah.
Okay. Hopefully, all right. So, when we expand this, the n factorial is the biggest, and you'll get n times n minus 1 times n minus 2 times n minus 3 times n minus 4, and there you would stop, because that will cancel out with what is on the bottom. And if I multiply the other side by 4 factorial, this is what I would get. So now my n minus 4s will cancel out. If you were asked to solve this one algebraically, you would have to expand this. And if you expanded this completely by multiplying it all out, do you see that you would get an n to the 4? And you'd have to multiply this side. And 35 times 16 is a big number. And then you would subtract it over, and you would have a polynomial that's an n to the 4 that you would have to try to factor. And that's where it would be complicated and really big. So instead, what we're going to do here is we're going to notice something. We're going to notice that these are consecutive numbers. Does that make sense? They're 4 in a row. Can you rewrite 35 times 4 factorial as 4 numbers in a row? Well, right now I've got 35 times 4 times 3 times 2 times 1. But those aren't consecutive, are they? What can we break up? 35 is 5 times 7. So now I've got 5 times 7 times 4 times 3 times 2. I don't need to write the times 1. But how many numbers is that? That's 5 numbers in a row, and they're not consecutive. So what was someone said 6? 3 times 2 is 6. So if I change that to 6, then I have 7 times 6 times 5 times 4. N is going to be the biggest one, 7. Yes? No? Okay. Looking back again, what did I do? I took 35 times 4 factorial, expanded it out. I even expanded 35 to be 5 times 7. This here is 4 numbers multiplied by each other, because this side is just n times n minus 1 times n minus 2 times n minus 3. And all 4 of those numbers are consecutive, because this is 1 less, this is 2 less, this is 3 less. I needed to figure out how I was going to write this, which is 5 numbers, as 4 numbers in a row. I couldn't do anything with the 7. The 7's for sure going to be there. But 3 times 2 is 6, and that fit right there in the middle. And then I'd still have the 7, the 5, and the 4 left. And that's 4 in a row that are consecutive. The 35 came from the question to begin with. So I'm going to leave C and D for you.